The authenticity of our food is a growing concern. Products such as wine, honey, and juice can be high-value items, which are an attractive target for scammers looking to make a profit, passing off inferior or cheaply produced products as high-quality, desirable commodities.
There is a substantial amount of fraud and adulteration. It comes in multiple forms. The most simple of which is adding what's called inverted sugars, such as corn syrup, or rice syrup, or beet syrup, to stretch the honey to get a higher price for a lower quality product.
We reject over 30% of non-complying honey every year. We can find false botanical and geographical origin. Sometimes you can have on the label Acacia honey from Hungary mentioned. When we analyze it, it is not complying. It could be a polyflora, not coming from Hungary, but for example, coming from China.
One of the main things we have down here is blueberry honey. That looks quite different than most of the other things in the database so far. So we can see specific compounds in our spectra that says, oh yeah, this is from blueberries.
Honey in and of itself is supposed to be 18% moisture or less. And many of these honeys, when they're harvested, are about 50% moisture. And so what they're doing is that they're pulling that off of the hive at 50%, and then they're drying it before they bottle it as honey. So you still have sweet, sticky stuff, but is it really honey? No, not really. Testing for those types of adulterations is very difficult until now.
Part of what NMR helps with is that it allows us to stay ahead of the scammers here, because now we start seeing, we get a really good idea of what should be in that honey. Then they can't just come along with some other new technique or something. They have to replicate everything that is in the honey. It no longer becomes profitable for them to slip in something cheap like rice syrup, which costs a tenth of what real honey does.
Bruker's Food Screener is a fully automated tool based on magnetic resonance, which allows food producers and retailers to ensure the quality and authenticity of their products before they go on the market. Its unique targeted and non-targeted analysis allows the determination of purity, compliance of origin, composition, and freshness. First, samples are set up in the software using a barcode scanner. Labels are printed for the sample tubes to allow them to be tracked throughout the process. A small amount of each honey sample to be analyzed is then weighed out into centrifuge tubes. The samples are diluted with water, mixed and centrifuged to prepare them for NMR analysis. The supernatant liquids are transferred from the centrifuge tubes into pH tubes, ready for automatic pH adjustment using the Bruker BT pH unit. The BT pH unit measures the pH of each sample and adds acid or base as required to adjust them to one preset value without manual interaction. This prevents variations in the NMR chemical shifts due to pH, allowing precise quantification and excellent reproducibility between users, labs, and instruments. When the pH has been adjusted, the sample can be transferred into an NMR tube and inserted into the sample changer of the NMR instrument. Transferring samples into the auto sampler is straightforward, as the next empty holder slot is automatically moved to the insert position. The rest of the analysis procedure runs automatically, with no more manual interaction required. When the analysis is completed, an analysis report is automatically generated for each sample. The report combines quantitative and statistical analysis results, indicating if the honey sample is compliant to the declared geographical origin and floral source, if it is typical to the reference honeys in the database, and if it contains sugar syrups. For more information about the food screener, visit www.bruker.com.